This laptop charger looks like trash. The cable is broken. It no longer powers anything. And most people would throw it away without thinking twice. Today, you're going to see how this broken charger is turned into a working soldering tool using simple parts you can find at home. Follow each step carefully, because the result depends on how well everything is connected and controlled. Start by preparing the charger. Take a utility knife and carefully strip the outer insulation from the output cable. Work slowly and avoid cutting too deep. Once the insulation is removed, the inner wires are exposed. Separate them and clean the ends so the copper is visible. This is where the power will be transferred. Bring in a multimeter and check the output before going any further. Switch to voltage mode and place the probes on the exposed wires. The display shows 24 volts, which means the charger is still fully functional and capable of delivering enough energy for this project. Now prepare 2 additional wires, each with an alligator clip on one end. Strip the insulation from the other ends and make sure the copper is clean. These wires with alligator clips make electrical connections quick and secure, allowing you to attach and detach power without tools. They provide a stable contact that reduces resistance and helps current flow consistently, which is especially useful during testing. Adjustments, or temporary setups where flexibility and control are important. Slide heat shrink tubing over the wires before making any connections. This step is important for safety later. Connect the wires to the charger output. Match positive to positive and negative to negative. Hold them steady and secure the connection. Once everything is aligned, move the heat shrink tubing over the exposed joints and apply heat. The tubing tightens and seals the connection, creating a safer and more stable setup. At this point, the power source is ready, but it needs a proper tip to convert electrical energy into heat. Take an old AA battery and check it with the multimeter. The reading is low, which means it is no longer useful as a battery. But inside, there is still something valuable. Use pliers to break open the outer shell and carefully remove the internal parts. An AA battery consists of a metal outer shell, a plastic wrap layer, carbon powder inside, and a central graphite core at the center. And it will become the core of the heating tip. This material can handle high temperatures and conducts electricity in a way that allows it to heat up quickly when current passes through. Clean the graphite rod using a cloth. Remove any remaining residue so the surface is smooth. Mount the graphite rod into a drill chuck and tighten it securely. Turn on the drill and bring sandpaper close to the spinning rod. Begin shaping it slowly. Create a pointed tip that can focus heat in a small area. Keep the movement steady and avoid applying too much pressure. Once the shape is clean and sharp, stop the drill and inspect the result. Now prepare an old spark plug. This will act as a holder and connector for the graphite tip. Take a threaded connector and attach it to the top of the spark plug. This threaded connector is compact, locks firmly with a set screw, and provides excellent electrical conductivity along with strong heat resistance. Tighten it firmly so it does not move during use. Insert the shaped graphite rod into the connector and secure it tightly. The graphite must stay fixed in place because it will be exposed to heat and pressure during operation. To make the tool easier to hold, prepare a plastic tube. This will become the handle. If you have a better idea or a different way to do this, write it down in the comments so the whole community can see it. Drill a hole through the side so the spark plug can fit through. Use a utility knife to remove burrs from the plastic tube, creating a cleaner, tighter fit for a more secure connection later. Align everything and push the spark plug into position. Adjust it so the graphite tip extends out from the front while the rest of the structure stays inside the handle. The tool is now assembled, but it needs to be tested carefully. Plug in the charger and attach one alligator clip to the spark plug body. Take the second clip and bring it close to the graphite tip. When the connection is made, a small spark appears. This shows that current is flowing through the graphite and generating heat. Now move to the first test. Place a wooden block on the table and position two metal blades so they touch at the edges. Secure one alligator clip to the blades and bring the graphite tip into contact with the joint. As the tip touches the metal, the temperature rises quickly. The contact point begins to heat, and within seconds, the metal softens and bonds together. Hold the position steady and allow the joint to form. After a moment, just remove the tip and let the metal cool. Then, take the blades and try to bend them apart. The joint holds, showing that the connection is strong. Next, test the tool on electrical wires. Strip the ends of two wires and place them together. Bring the graphite tip to the connection point. Heat builds quickly and the copper begins to bond. Maintain steady contact and then remove the tip. Pull the wires in opposite directions. The joint remains intact. This confirms that the tool can handle basic soldering tasks. Now move to a real repair situation. Take a metal cup with a broken handle. The joint has failed and the handle is completely detached. This setup is simple, but it demonstrates how understanding materials and connections can turn discarded items into useful equipment. Position the handle back in place and secure it. Attach the alligator clip to the cup and bring the graphite tip to the broken joint. Heat builds at the contact point, and the metal begins to fuse again. Once the process is complete, allow the metal to cool naturally. Then lift the cup and tap it gently against the table. If you have an old charger at home, consider trying this method. Share your results and improvements, because small adjustments can make the tool even more effective. Stay with the channel for more workshop ideas where simple materials and practical thinking turn everyday waste into tools that actually work.